We're going to look at Chapter 14, and we're in Section 4, so it's evaporation and vapor pressure. We're going to look at evaporation and vapor pressure, and molecules of a liquid we know can escape a liquid surface and form a gas. That's called evaporation when we have it happen at room temperature. Endothermic process is what this is because it requires energy to be put into the system to overcome those intermolecular forces between the molecules, which allow the molecules to go from a liquid to a vapor state. In vapor pressure, the amount of liquid is going to first decrease, then become constant in a closed system. Condensation is the process by which vapor molecules convert to a liquid. And while we're having condensation, evaporation and condensation back and forth, when there's no further visible change in this closed system, we have reached what we call equilibrium, where it's evaporating and condensing at the same rate. Vapor pressure is the pressure of the vapor present at equilibrium. The system is at equilibrium when no net change occurs in the amount of liquid or vapor because the two opposite processes exactly balance each other out, just like the picture in the last slide. What is the vapor pressure of water at 100 degrees Celsius, and how do you know? The answer is at 1 atmosphere. And how do we know that it's 1? We know that at 1 atmosphere, water boils at 100 degrees Celsius. So when we are at 1 atmosphere, 100 degrees Celsius, we should see water boiling. Liquids in which the intermolecular forces are strong have relatively low vapor pressures. So we know the water has really high intermolecular forces between the molecules, and you'll notice that there's not much pressure put in this barometer with water. So once this is reached, this water vapor has reached equilibrium, there's not a lot of change back and forth, not a lot of evaporation to condensation. But if you look over here at the diethyl ether vapor, it has a high vapor pressure. That means it's very volatile and that it goes into gaseous form rather quickly. So we're going to see this when we do the lab. We're going to check the vapor pressures of various substances and see how quickly they evaporate and which ones are more volatile and less volatile, and compare their molecular mass and the intermolecular forces as well. Which of the following would be expected to have highest vapor pressure at room temperature? So we notice that we have a lot of things in common. We have the groups of C's. Here's the difference here at the end. So when we look at this, we notice that this one right here has a hydrogen bond in it, and that I think would cause it to have a lower vapor pressure. The one probably that doesn't have the highest vapor pressure is going to be the last one because it's lighter weight and everything in it is covalently bonded with very little dipole moments going on. And so it's going to have weaker intermolecular forces, and those weaker intermolecular forces are going to allow it to evaporate quicker. And this finishes up 14.4, and that's going to lead us to the lab with your temperature probes, so make sure you have good batteries in your calculators.